So we see lots of interest from our customers in running deep learning algorithms for a range of tasks. One of the most common is object detection. But what we quite often see is they're not necessarily making the best choices about the selection of networks or how they're choosing to analyze the applications. So the purpose today is just to try and give a bit of insight into for kind of object detection. How what are the kind of choices and things you can look at when you're targeting embedded market. So I'll give it a bit of an introduction in a minute to imagination technologies and the space that kind of we're looking in and set the context for this talk. And then I'll look at some kind of key object detection networks and kind of look at how well they're suited for embedded vision or not. And then look at taking some of those and some optimizations that can be made to make those networks better suited. And then some summaries at the end. So just to introduce people, so as the introduction said, so I work for a company called Imagination Technologies. For people who aren't familiar with us, we develop hardware and software IP, typically licensing to semiconductor companies as part of their SoC design process. So I'm part of PowerVR. Within PowerVR, we kind of got a long track record, long history in graphics and GPU technologies, amongst other things. And more recently, we've been investing heavily in developing vision and AI technologies, both using our GPUs, but also dedicated hardware as well. We also have communications IP, so part of Imagination Technologies called in Sigma, looking at Bluetooth, Wi-Fi, that sort of thing. Worldwide, since the company's been in existence for sort of around 20 years or so, over that time we've shipped IP in something like 10 billion units. And we're based in the UK, just outside London.